Okay, I guess we'll kick it off. Um, yeah, I don't know if you guys are going to be hopefully hacking with us today, but I thought we'd go through some of the docs and just some basic things to get you going. Don't have a lot of time to delve into a lot of the details, so find us after and we can help. But for the most part, Essential is a declarative blockchain. The idea with the declarative model is that instead of proposing or submitting transactions to the blockchain that specify how the contracts should execute certain algorithms to update the state imperatively, you're going about this the other way around, where you're basically submitting solutions that tell you what the next state should be. So, for example, what your balances should be at the end of a particular block or at the end of a particular solution submission. And the job of the validators using the contracts is to make sure that that final state is allowed. That final state is possible given certain constraints. So basically, a contract is just a collection of constraints, and those constraints make sure that the state, is not being updated in random ways. The constraints restrict the state updates to a specific space of some sorts, and what you're going to end up with is every section of the contract will allow you to update the state in a way to achieve a certain task. For example, whether it be the transfer from one account to another, or be it a minting of a token in a token contract, and so on. So I encourage you guys to go through the docs first. There's lots of information here about all the declarative versus the imperative concepts, how declarative chains, or specifically our chain, differs from imperative blockchain, as well as the difference between declarative and imperative programming. Yeah, you might be familiar with imperative programming from languages like Solidity and so on. And then there's a bunch of stuff about the protocol itself, which you might find interesting. And probably the most important place to start actually getting things going is with the Getting Started guide, which if you go to in here, basically has an application, an example application, which is the counter, the canonical counter, which increments by one every time you submit a new solution. And so you should probably walk through this line by line and get it going. It basically describes how to start a new project, how to compile it, what the output artifacts are, and then lets you interact with the contract using a Rust front end. A lot of we currently only have a way to interact with contracts using Rust. If you want to build a full application, you can probably build something in TypeScript. That's going to be a little more involved. But a lot of the infrastructure we uses Rust. And so this Getting Started guide goes through how to build a Rust front end and a bunch of Rust tests if you want to test your application. And eventually, there's some form of a CLI that also provides some examples of how to do a lot of that in the command line, and then end up with a way to interact with our deployed DevNet as well. So with the counter example, I think might be interesting to go through just as quickly, just a final form of a contract that increments a counter is this one, which, as you may see, we have our storage, which is the counter, and we have a predicate, which is kind of similar to a contract method, but it's not exactly called, and it's this whole thing where you're actually solving the predicates, which you can solve multiple predicates at the same time. So there's no call, there's no control flow. You just have this object here that has a bunch of constraints, in this case, just one, that tells you how the counter is allowed to be changed. And in this case, the counter, counter prime, which is our notation for the next state, we're saying is the counter prime has to be equals to counter plus one. As you see, this is kind of a Boolean expression. And nowhere in here do we actually change the state manually. There is no manual state update in the contract. It's all done by providing, like the solution will propose a new value for the counter, and then the validators will check whether this is valid or not by plugging in the new value, plugging in the old value, and then checking if the constraint is true or not. And that will happen for every constraint, and that will happen in parallel. So that's kind of the idea behind the whole thing. Is smart contracts are basically gatekeepers. They're just there to check whether the state you want, whether your future, whether your desires can be possible or not, whether if the contract allows you to go from point A to point B, then it will happen. And if you're doing something wild and that's just not possible, then the contract will not allow you to do that because at least one of the constraints will fail. So for the most part, you can probably build anything you want. Whatever can be built on imperative chains like Ethereum, you can probably do here as well, or you should be able to. But we think this also opens up avenues for other applications to be built in hopefully a simpler and more efficient ways. And I know in the previous hackathon, some people built a limit order book, and that was fairly easy to do, which was nice, which probably can't be said about other ecosystems. So once you go through the Getting Started guide, there's a bunch of videos I think we'll link to if you go to the price page. There's a video here that has more information. It kind of walks through the token contract, or at least parts of it, which you might find helpful. And if you want to venture to this repository called Essential Integration, which I linked to in the Telegram group, and we can link to in Discord as well. That's a very important repository. Under apps, you'll find the counter, the full counter example, with multiple implementation of the front end, but also the token example, which is really important. A lot of applications will probably want to use this token. And potentially, it will inspire you to implement things in maybe different ways. So the token example, if you go to the pint/token source contract.pnt, this is the Pint code that describes the token functionality. And you'll get used to a lot of this stuff. There's a lot of boilerplate stuff in here. But effectively, the core logic of many of these predicates is the invariant you think of when you think about a transfer or a burn or a mint. For example, when you think about a transfer, the invariant is you want one balance to go down by an X amount and one balance to go up by an X amount. And so you encode that in some constraints. For a mint, you're saying you want to create tokens and then send them to a certain account. So there's an invariant for that says the balance of that particular account has to go up by some amount. And then I have to increase and then the total supply has to be moved by the same amount, and so on. So all of these invariants are constraints. They're not actions. You're not saying I want to change. There is no assignment. Like you're used to saying, the value of X must be assigned to or must become this. We don't have assign. There is no assign operator in this language. It's all constraints. It's all Boolean expressions. So everything here, as you can see, is temporaries and just constraints. And every constraint takes a Boolean expression that says what the invariant is to accomplish a certain action. And so you can think about, if you're designing a DeFi protocol of some sorts, all you have to do is think about what the math is, what are the invariants that take you from state A to state B, and then you plug those into constraints in your contract. You don't have to think too much about how to get there. If you need some form of algorithmic computation to actually get there, then hopefully that gets done off-chain. So the point is, a lot of that complex heavy lifting should be done in your front end. So yeah, I would encourage you to really read the token contract and then go back to token and then go to the app. Under source, you'll find a front-end implementation in Rust that allows you to interact with the contract. And then there's a bunch of tests that also show you that, use the front end and show you how to create a wallet, how to sign, how to do all the authentication stuff, how to, invoke methods from the front end to submit solutions to the contracts to change the state. Yeah. If you can digest everything in this particular application, you'll probably be ready to build anything you want. So yeah, I will probably stop here. We have 5 more minutes. If you have any questions or if you have, we can talk about questions now or after. Yeah.
So if you want to build like something like an
yeah.
and so essentially you will need math to calculate, I don't know, whatever tokens you're gonna get on the other side. How does that work? Does the off-chain computation does everything and sends the end desired results, and then the constraints actually check the...
Exactly, that's the whole point of this whole thing.
Oh, so yeah. All the algorithmic computation is off-chain, and then you just make sure whatever you're sending to the contract, it is a valid output?
Yeah, if the constraints allow it, if the constraints are satisfied with that final solution, then you're good. Then the builder will build that solution, will include in the next block, the validators will validate it, everything will be happy.
I see.
Then the state will be committed. And if one of the constraints fail, then it's just going to get rejected. Yeah, that's literally the whole point of this approach, is just move there's many objectives to this, but one of the benefits is that we're moving that complex stuff off-chain. Because if you think about it, what a database is, or what a blockchain is, it's a database where all you care about is updating state from one
it's a state machine.
It's a state machine. And so doing everything and anything on-chain is kind of a weird... it's obviously useful in some cases, but it's not really the point of a blockchain in most cases, for most applications. And I know a lot of Solidity applications try to do this in an indirect way where, let's move as much stuff off-chain and try to keep the contracts somewhat only caring about start and final state. But in here, it's all done at the protocol level. Everything is made for that purpose. So yeah. We'll talk about this more. I'll be here for the next 2 days, and there's a lot of my colleagues who can talk to you about that stuff as well.